All right, Algebra 1A students, welcome to part 2 of your video on lesson 6.5. In this video, we are going to be talking more about linear inequalities. Now, in our last video, we looked at linear inequalities with two variables and talked about what their solutions look like as coordinate points x, comma, y in parentheses. Now, in this video, we're going to graph the boundary lines for these inequalities and shade half the graph to show all of these solutions. Because remember, there are infinitely many solutions to a linear inequality. We're going to show that in this video on a graph. Okay? So the first thing we have to realize is when we finish, our answers are going to look like this. There's going to be a line through in the coordinate plane, and then we're going to shade, they've done it in yellow here, shade half of the coordinate grid to show all the solutions. Now, you'll notice that this line here is a dashed line there, and this one is a solid line, and there's a very key difference between a graph with a dashed line and a graph with a solid line. Okay, so the graph with a dashed line has no equal to line on its inequality, right? This says y is greater than, right? Greater than or equal to, just greater than or equal to, without the equal to line. Sorry, just greater than or less than without the equal to line. Now this line here is solid because this inequality has the equal to line. It says either greater than or equal to or less than or equal to. So there's a very key difference between a greater than or equal to inequality and just a greater than inequality. So hopefully that distinction makes sense, and you'll see an example here in just a second of how this is going to work. Okay? You'll be given problems like this where you're given a certain inequality, y is greater than x minus 2, and you are asked to graph that inequality. All right? The first thing we have to do is rewrite that inequality as an equality or as an equation. Y equals x minus 2 is the boundary line for this inequality. It's exactly the same thing, except instead of a greater than sign, it's an equal to sign. Now this is the type of thing that we have been graphing for much of this class. We started that way back in chapter 5. And this equation right here has a slope of 1 and a y-intercept of negative 2. So I start from my 0, 0 point, go to negative 2 on the y-axis and put a point there. And then my slope says to go up 1 and over 1. 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 So on and so on and so on. Now, once I have all these dots, I have to decide before I draw my line, is it going to be solid or is it going to be dashed? And in this case, because of this symbol here just being greater than and not a greater than or equal to, I actually need a dashed line to go through all of these points. Okay, so I'm going to take a dashed line and put it through all of these points. All right, so that right there is my boundary line. That is my boundary line right there. And now I need to decide which half of my graph am I going to shade in to show that they are solutions or points that work in this inequality. All right? Now, I can either shade in this side over here, or I can shade in this side down here. This side or this side. In order to figure that out, I'm going to test a point to see if it works. And the point that I always like to use is 0, 0. I think that's the easiest point to plug in for x and y. So I'm testing this point right here, 0, 0, to see if it works. If it works, I'm going to shade in this side of the line. If it doesn't work, I'm going to shade in the other side of the line. So I take my point 0, 0 for x and y, and I plug it into this inequality up here. And I say 0 is greater than 0 minus 2. Okay? 0 is greater than 0 minus 2. I'm going to simplify this down just a little bit. It ends up saying 0 is greater than negative 2, and I have to ask myself, is that a true statement? is 0 bigger than negative 2 degrees? Right? If you think about it in terms of temperature, maybe that's easier. Is 0 higher than 2 below? Right? 0 greater than negative 2. The answer is yes. Because the answer is yes, I'm going to shade in this entire side of my graph. Oops, I went over the line a little bit. So I'm going to shade in that entire side of my graph, and that is all of my solutions. Every point that's in the red area works for that inequality, so we can see there are a lot of points. There's infinitely many points, right? But it all started with graphing that line and then picking a point and testing it to see if it works, right? So I have one I would like you to try as well. What is this graph here? I will bring in the graph to show you later. So try this inequality. Your y-intercept is a 1, your slope is a 1/2, so graph your line and then decide which side to shade. Once you've finished that, come on back and I'll show you what you should have. All right, as I mentioned, your y-intercept is a positive 1, so I start there, and my slope says up 1 over 2, up 1 over 2, and so on like that. And now this line actually needs to be solid because there is an equal to piece to this inequality. It says y is less than or equal to. So I need a solid line this time. Okay. Once I have that graphed, I'm going to check the point 0, 0 again, and I'm going to see if it works or if it doesn't work, and that will inform which side of the line I should shade. When we put it in, we end up with 0 is less than or equal to 1. That is absolutely true, so I am going to shade in this bottom side of my graph. Shade it in, shade it in, shade it in, shade it in, and I'm done. All right? It all starts with graphing a line, then deciding which way to shade. If you have questions about how to graph a linear inequality, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.